Hi, Peter and Roger. No, you're not Roger.
I'm not Roger, sorry. No.
Sorry. Because I always
We
write.
should leave this in. This should be the take.
Hi, Peter and David.
Hi,
Good to see you both again. So how about we talk a bit about data science and statistics?
Yeah, absolutely. Peter, you're an eminent statistician. Why don't you kick this off?
Well, eminent or not, I think the important thing to recognize is that statistics and data science can benefit from some mutual interaction. And you know, in the last 10 years, I've seen the attitude of the statistics community to data science change from seeing it as a threat to seeing it as an opportunity to expand our relevance. And you know, we can learn from data scientists, and we can teach data scientists, and vice versa. Yeah.
Absolutely, and I love this. That transition, I feel, started in some ways at the World Statistics Congress a few years ago, where people were feeling this as a threat. And after Hadley Wickham gave his talk as a data scientist, you know, the president sort of said, you know, but isn't data science really, you know, just part of applied statistics? And Hadley Wickham had a wonderful response, which was, it maybe could have been, but that ship has sailed.
Yeah, sure. Yeah, and I think this really underlines some of the things we can learn from data scientists, which is that we really need to take a much more professional attitude to coding and implementation than we've done in the past. And instead of thinking that once we've got an article in the journal, we're done, we need to follow that through to tools that other people can use. And in particular, I think the data scientists, you know, have a culture which is much better at capturing the need for reproducibility of findings because of its emphasis on coding and implementation of solutions. And we have to learn from that. And I think conversely, what we can perhaps offer the data scientists is perhaps a better understanding of why, when you collect a data set, that's not the beginning. The data set has its origins. It has its origins in a scientific context, and that scientific context matters. It has its origins in a study design as how the data were extracted from that scientific context, and that matters. And then finally, that we can formalize all of the uncertainties that surround any real data set through the unifying mathematical theory of probability, both in how we build our models and in how we express our conclusions, so that we appropriately temper our conclusions with our degree of confidence or certainty in their accuracy. And we try to do that as precisely, but at the same time as honestly as we can.
Yeah. And one of the things I think which is really interesting, of course, is that sort of this data sources, and you know, this thing about learning from one another often comes to the fact that statistics is born in data scarcity, when, you know, we had to be very get the most out of the small amount of data we could have. Whereas the world we live in now, there's this data abundance, and you know, we're able to use data which is coming from so many different sources, and so there's a whole different mindset, and I think the statisticians have a lot to learn about sort of just, you know, being able to sort of deal with that data abundance. But one of the key things which is relevant to this course is that actually a lot of the sort of systems that statisticians have put in place over the years are to protect them from misinterpretation and from getting things wrong, to be responsible. Yeah, and so the responsible part is something where I think the data scientists can really learn from what the statisticians have put in place to help statisticians be responsible.
Yeah, I agree. And really, you can think of that as an aspect of design, that even if you haven't designed an experiment in the classical sense, you are making choices as to what data to extract from the wealth of data out there in order to answer a particular question. And that's a design. You're designing your study in terms of which data you collect and which data are superficially relevant, but are not perhaps as trustworthy as other data. So that simply getting more data doesn't necessarily give you better answers.
Exactly. Yeah, you're designing which data you're using from a sort of bigger amount of data that could be used as part of knowing which questions you're trying to answer.
Yeah,
because
precisely.
that really makes a difference. Some of the
Yeah.
data is more trustworthy for certain questions than other data. And so understanding the relevance between the data you're using and what you're trying to do with it really matters. And so that idea of thinking that through as part of the whole process is really important.
Yeah.
I think the last thing maybe to just sort of tie this up is sort of, as we go forth, this course is really intended for data scientists, but a lot of it is sort of coming from bringing some of these sorts of ideas which have come out of statistics, sort of ideas of where misrepresentations of data come. Do you have something to sort of say as to why you feel this is so important, that these ideas are sort of more widely understood?
Well, yeah, because we have an enormous opportunity with the increasing availability of multiple data sets to give better answers to important questions. But it's not a free lunch. And it does mean that we have to think about some of the more traditional aspects that have perhaps been forgotten in the sort of apparent luxury of having unlimited data to analyze.
I mean, it might not be forgotten. It's about rushed through is maybe the sort of thing. And when now the whole emphasis on actually being responsible is forcing people to sort of maybe take a step back, slow down a bit, maybe,
yes,
and actually think more deeply. So, I think maybe it's the distinction between AI and responsible AI is exactly where people actually start thinking about these things more deeply.
Yeah, I'd agree with that.
Great. Thank you, Peter.
Bye, David.